All right, hi everyone. Happy Monday. Filming this on Friday, so no idea how the soccer games go this weekend, but hopefully they were good and you enjoyed them. It's been a wonderful World Cup. I'm Matthew Wilson, CEO of Sterling Metals, and with me, Senior Vice President of Exploration, Jeremy Niemi. Hey, Jeremy, how you doing?
Well, very good. Lovely Toronto weather. I'm in Toronto these days, so heading to the project on the weekend, actually next week. So I'll be up in the Sioux next week.
So when we are showing this video, you will be in the Sioux, and I think that at this point we will have geologic AI up there with our core scanning facility ready to go. It's been a little bit of a delay right now, but excited to get that going. So much drilling has happened on the project. And then in this scenario, we're going back now, I suppose. When did we drill these holes? We drilled these, what, 789 were drilled in April?
I think so, yeah, that would make sense.
In April. So it's always an odd thing to go through things. It's nice. It's a nice exercise, I think, to go to revisit the actual grades when you get them, and to see the context of the system that it's kind of providing. And so as we go forward here, it seemed like a good idea to each press release that we put out, we're going to just kind of touch on it, explain like why, what we're excited about, what happened, what didn't happen, and walk through it each time so that there's a little bit of context that goes on. There will definitely be some forward-looking statements. We'll just throw this in here every time for those of you in need of this kind of disclaimer. For context of where this project is, again, Sterling Metals, our flagship project, the Sioux Copper Project, located in this quadrilateral of mining in northern Ontario. Jeremy's hometown of Sudbury, the historic gold mining district of Timmins, Wawa, Alamos, Island Gold, and here we are with the Sioux, an hour north of the Sioux Copper Project. Recently, as we've announced, we have our area where Jeremy will be staying and the core scanning will take place, this Copperstone Ranch. There's a few videos we put out a couple weeks ago. We had a great site visit up there. Man, that site visit we had up there was so fun. We had John Thompson, we had Neil, you had you, me, Crystal. It was so great finding porphyry from Copper Corp all the way over to Tribag and just understanding. Do you think that there was one thing that came out of that site visit that we all kind of agreed on with this system?
Oh, a couple things. There's the word thermal cupola stuck with me, in that this rocks have been heated. I used the expression the other day, a reverse sear, like if the rocks have been almost prepped and heated, and we have a really strong copper system, and it maybe permeated further because of that preparation. I thought that was a really fun concept that came out of the week, and yeah, I agree. It's always a treat to get some fresh eyes, some really experienced eyes, like John's, there, and these sensational discussions, like while standing in front of core and not being eaten alive by bugs, which was bananas.
That was a very fortunate thing. It was
I,
fortunate. Luckily,
the
our core facility there is just so amazing because you can sleep. We just kept rolling out of bed with our coffee and going to see new core that was delivered in the morning. Um, and then there's the
Christmas morning.
sun rising, sparkling on sulfides as we just look at our coffee. It was a pretty fun thing. But coming back into this into our current thermal cupola, giant copper system, we made it to Copper Corp where we found a whole bunch of porphyry rocks and chalcocite outcrops that are seem to somewhat have some sort of association together. Tribag, there's a whole bunch of porphyry rocks up there associated with breccias at surface. And it's interesting to me because a lot of what we've been saying is that, it was a buried porphyry and everyone missed it. No, no, it's there. We found it at 7 meters depth, these same porphyry dikes that we're finding at MEPS. So this fluid conduits that we seem to be dealing with is very common across this 30-kilometer mineral system. And so I think we all came out being like, oh yeah, it could be some mix of other systems, but definitely it seemed that there was a conclusion at the end. It was like, yeah, all right, big porphyry system. Seems pretty fair things to say. So these holes that we've been testing at the MEPS discovery, it's important to stress, I think, that this is a 30-kilometer mineral system, two old mines on bookends. And where we started with was an old discovery of a porphyry. And what we've gotten to now, so 7, 8, and 9. So we've drilled 30 holes this year. And when you zoom in on that, those are rock samples in and around it that we've been taking. So this is the plan map. And I think it's a lot better in 3D than it is in 2D. So we put it out in the press release in 2D, but in 3D, you really start to see a lot more. And what you pointed out something to me when we looked at it. What's the one thing that we noticed and we are filling in, I suppose, as we go here.
Well, I mean, last fall we north is up here, so we went around the north side of the valley and headed west. We drilled those holes, and then we came back around, and we left this like corridor in the middle. Well, we didn't leave it on purpose, but it just so happened that that was the case. And that really seems to be an important part of the mineralization trend, and an area that we no doubt are going to be doing some more work. So, and these holes frame, I think, that, especially, hole nine, and I don't know. I think it's these holes are pretty important for next steps. All of the first nine holes really have been leading to what's next, and of course we have 20 holes or so coming already that are drilled, and just got news we started our 31st hole, so that's started today. So I think things are coming along nicely.
So what is it that we were testing? What were we only had phases in this program, right? We were testing new things logistically at the first three or four holes. And then what were we testing here? Like what like some of these holes were big holes, right? They went pretty
Yeah.
deep. Like what and we talked about that porphyry stock underneath in the source. And so what happened here? Like what were we trying to test this? So just before we get into that. So this is the three holes. This is the color from three holes that we released. And if you look at it, and the corridor that we're talking about is like this right there, which we'll come back to in a second. But just when we look at it in section, and we spin just a bit here. Okay, so these were long holes. So what were we testing? What kind of happened with this? The grade is not jumping off the page here.
Yeah.
What were we testing? What happened? And what were the good and the bads out of these holes, would we say?
Well, I think the mineralization starts at surface. So we are always testing this scope and scale of this robust system that pokes out of the ground. We know it's big, but it's like how big? What are the dimensions of the drilling as we go towards the northwest? So holes 7 and 8 drill towards the northwest. We are always looking at the higher grade parts of it, and we're starting to see covellite in addition to bornite. So we're trying to understand the structural controls that maybe are guiding us, and where these higher grades are, where the covellite and bornite are concentrating. And really like that valley. There's a valley that runs along the west edge of MEPS that where some of these holes are going. But also the tail of the holes, looking at the stock. We were fortunate enough to inherit that ZTEM survey when we started here. That was flown back in 2014, and we have squeezed it and used it in helping us to understand the plumbing, the architecture of the copper system here, and it's done a pretty good job of leading us to where the stock is. And so the tail ends of 7 and 8 were really, that's what they were doing, is going down into the stock, um, looking for the source of this mineralization we're seeing at surface. And like I said, always we're looking for higher grade parts of the system that really juice it up and get us excited, but get everybody excited.
So like the broad mineralization, I think that so for me, the covellite zone that we were talking about in hole 22, we had this 15 meters at the end of hole 22 here last year. And there was covellite and bornite, and there was, 0.3 grams gold. And so I think it was 15 meters or 1.5%. So a lot of what we were doing, we're trying to test, did it extend at depth? And the at least the way that the thought process is when you have this dike swarm theory, there's a source of the dikes
Yeah.
that's bringing all the grade, right? And that's really what we were testing here is the source right below it. And it doesn't seem like, while that is certainly porphyry stock below, and there is bornite and chalcopyrite and moly throughout the stock, little bits of it, but it doesn't seem like this is the high grade source of it all. And I think one of the things that seems to be very relevant here is just the lateral, like if you go back to this, just the sills that have been produced, where you see these flat line lenses essentially
Yeah, I think
of higher grade,
the
right?
certainly out of the drilling we've done, we've shown that even just last year, but with some of these early holes this year, that upper GFP horizon and the lower one, I think there's little doubt that they're horizontal. And what we haven't found is if they were branches of a tree, horizontal branches of trees, where's the trunk? Where's that part, the vertical part of the system? And that's probably going to be pretty important. And something else that I think these holes have um, led us to understanding a little bit better is that not all of the Archean host rocks are equal as far as permeability and good hosts of copper mineralization. Some are better than others. The copper is everywhere, but we have this tighter gabbroic unit where the copper is more in fractures and it's not permeated all through the rock, whereas in our basalts we see it more pervasively. We got higher grades. So there's another part to this story, like big, powerful system, but you need the right kind of rocks to sort of soak up the copper, as it were.
One of the things that was really interesting to me in this hole is that in hole 7 and 8, a lot of the hole is in the gabbro, right? And the biggest
Yeah.
difference when you look at the rock is that the gabbro, it doesn't look like there's a ton of copper in it. Like they just, you don't get these disseminated swarms of chalcopyrite and things. And yet it's still carried. It's zero point 0.3 the whole way through, 0.25, zero point 0.3. Like it's pretty consistent throughout. And the one thing that we keep talking about is the system is so strong that it even in bad rocks, it's making its way into there for easily ore grade materials. So it's a search for permeability here. And I think so. Nine, one of the things that we did notice in nine is that there was no lower GFP. So in our discovery hole in MEPS 2, in the holes MEPS 20, when you have 60 meters of 1%, when we had our 70 meters of 3, when you had MEPS 22, when you had and 21, when you have these big bornite areas where you see again 1, 2, 3% material. Usually you have that GFP, that fluid conduit that's down below the upper horizon. We didn't get that in nine. Do you think that we just drilled over it? Like is there a specific structure? I know that when you look at this again in plan and we
Yeah,
connect the
plan is
dots.
is is a good way to look at this because we also see whole MEPS one right in plan view, which MEPS one went south
Yeah,
and
and there's no GFP in that.
no GFP in that.
Yeah.
So obviously there's a north-south component to the extent of that GFP, no doubt going to be a structural part of that story. Copper keeps going, but the GFP and then those real booming grades, we don't see it. So it seems like nine, we just stayed a little bit too far south. Now, if we had to turn the hole more east-west, that's also got some risk to it because it's an east-west trending system. So I think still, I like this hole. I remember we were planning this hole. We were coming up. There's something going on through that valley, and
A lot of bornite. There's bornite throughout the almost the whole entire hole. It's just missing that big high grade flashy area, right?
yeah, I bet you if you turned the hole like 5 or 10 degrees
Yeah.
northward, it would have been a different hole. But it's a great spot, and I think I think that area is going to be important, and it's we drilled some of those last holes you can see just west of there last year that we had our ski hill, they call it,
Yeah.
pad.
Well, you had 50 meters of point 6 in here. You had 30 of point 0.8, and that's at depth below everything. And I think that, that's somewhere we've followed up already. And I think that this trend is going to be very clear. And really our next drilling, I mean, as we start to move we move all the way over here, and then we're moving all the way over here, and we're starting to basically show this 2 kilometer area. And so it'll be interesting to see how results come back from that.
Yeah.
But when we talk about all of the drilling that we've done, I think just it's always important to have context of, oh, that's not very nice. Thank you for bearing with me, everyone. So it's good to have context of where we're at. So MEPS is just this dot, right? And I mean, when you look at it in soils, I mean, the strength of soils as you kind of move down here, the gimlet target that we always talk about with all that bornite and outcrop here. We're currently drilling here, I think, right?
Yeah.
The start, right? Where we have porphyry outcrop, copper moly, 4% in A veins on surface. And so it's kind of a balance, right? We have this unbelievable productivity with our rig where you're doing 200 meters every 24 hours. And, these guys are so fantastic. And so we're moving quickly with one rig, but we're balancing between this MEPS kind of build out, understanding what's going on there, trying to work laterally, I think now I'd say is fair to say, where we're trying to find where that tree trunk is laterally as we go. And then right now we're stepping out a little bit to see what some other rocks and other areas can be and before we just head back. So exciting times. What hole are we on right now?
31. I look at it as like we're kind of framing new areas. We know we're onto something special at MEPS. Still more work to do at MEPS. But looking at some of the other priority areas in the vicinity, um, knowing that there's a lot more drilling and this, big system. Um, Another thing that really struck me when we were at site with John and Neil and the team, going back and looking at Copper Corp off to the west and Tribe Core off to the northeast is um, just how much space is between where we are now and those mines, those former mines, and how little work has been done there. It's pretty exciting.
Yeah, it's 30 kilometers.
Yeah,
Maybe make it to Tribag. And
yeah,
you had 7 million tons of 3% mined over here, intervals of porphyry and breccia. You have Copper Corp, which did 1.5 million, 1%. But then we were looking at just what chunky calcite in outcrop, right? Like just big
yeah.
rocks, right? And hundreds of meters of just like wild epidote. That was some green rock that we found over there in the very sad old core shack that's there now. But I think that's the thing. Such a strong system, very mineralized. These holes, not quite the right rocks, I would say, in that end, I guess would be the right, like the gabbro is just it just stops it from being really pervasive, but still able to push through right from surface. All going to the mill, all ore grade material, and just when you start seeing how it mixes with the high grade, I think is how the story is going to start to play out.
Yeah, and we're mapping. Like, we are drilling, but let's not forget we're doing some mapping, we're doing some prospecting work, we're doing other things on the ground this year. So mapping where the gabbro is. Again, gabbro is still mineralized. It just has
Yeah,
kind of like a grade cap on it. It's only going to get so mineralized. It just can't get higher because of the tightness of the
yeah.
rock. But some of the other rocks are great host rocks, and we're
We will be fine. We found that whole outcrop we walked to is I think somewhere over here. There's 6 meters of 3% copper and a gram gold over here. It's one of these things, 4 meters of 6 grams gold over here with some cobalt. Uh, it's a big system, and so we're getting going. I think we've only been drilling for 15 months now, and we've already started to outline. I'm excited to get these next results out, and hopefully we can keep having these chats as we go. So, um, thanks for that. That was great. If there are any questions for anyone that is watching, please reach out to us, info at Sterling Metals, social at Sterling Metals. Give us a shout, always, anytime. And yeah, hopefully now that we've caught up to the lab, we can have a bunch of news flow that gets going, and hopefully we find some grades to mix with this consistently very strong, pervasive mineralization. Jeremy, thanks a lot for your time, man.
yeah, thank you. Have a great weekend.